Hello, let's continue our Sudoku adventure with On Point by Riffclown. So we have normal 6x6 Sudoku rules in every row, every column, and every 2x3 box. We are placing the digits 1 to 6 exactly once each. Additionally, we have arrows in the grid. They're connected to circles. So the digits on an arrow sum to the value in the connected circle. So if this were, say, 2 and 3, we would sum those up, and that sum would be put in the circle. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, my initial idea here is we have this given 6 for a reason. And the reason I think that is because you can't put 6 on any of these arrow cells. Because if we did, then we would just immediately blow out the sum. Like, what would this sum to? We'd have to do 6 plus 0 is 6, right? There's no 0 in Sudoku. So this 6 looks down, for example, and we can't put a 6 on here. So we're going to have a 6 in one of these two. This 6 also needs to go up here somewhere, and it can't go on the arrow, so it goes here. These two combine and look down, and we can't put a 6 on this arrow either. So these point right, this looks down, can't put a 6 on this arrow cell, so the 6 goes here. Now these two 6s look up, and we can't put a 6 on the arrow, so the 6 goes here. And it looks like we're left with kind of these 6s here, but otherwise we have them all. All right, how do we follow up with that? I think it's worth noting that these ones can't be 6, so they add to 3, 4, or 5, and this one's not a 3. I don't think it's worth putting 1, 2, 3, 4 on all of these. I don't think that's what we're supposed to do. This 3 might come in handy. I'm trying to figure out what to do with the 3. Okay, I think I see what to do with it, actually. So we need to do a little bit of geometry here. So let's make this cell green, just to give it a color. So whatever value this cell ends up, we know it's 3, 4, or 5. We don't know which, but we can talk about green. So green is going to go in this box somewhere. We don't know where, but it's going to go in this box somewhere, whatever digit green ends up being. But we also know it's not going to go here because it can't share a column with green. We also know it's not going to go here because if we put green on its own arrow, then again, we'd have to put a 0 to go with it in order for it to also add to green. There's no 0. So green doesn't go here, green doesn't go here. And what we do know about green is it is not 6. It's 3, 4, or 5. And so where does green go in this box? Only exactly one place. It goes here. So this is also 3, 4, or 5 because these are the same digit, but this sees this given 3. So that's not a 3 and that's not a 3. So now we have this 4 or 5 pair. I like to color the other of the pairs if we ever find them, just to keep track of that. So I guess one thing I can say is let's keep following up with these greens. These greens look up and we know green's not 6. So green goes on this arrow. So with 4 or 5, we're going to need a 1 or a 2. Where does purple go in this box now? Purple looks up, and these are not purple. So purple goes here, which makes this one a 1 or 2. This is going pretty nicely. And of course, now that we have that, these purples look down, and that puts a purple somewhere on this arrow. Well, if purple's on this arrow, then it must be smaller than green. So purple has to be the 4 and green has to be the 5. And then this is a 1-4 pair because it's got purple on it. And then we can clear out all of our colors. Very nice. So this is 1 or 2. Actually, it's a 1 because this 1-4 pair looks up. So these can't be 1s. So the 1 goes here. That's 2 and 1. Oh, we knew this was 1 also because the 6 sum. I just wasn't looking at it. This is a 2-3 pair. So this is either 1 plus 2 or 1 plus 3, which means this can't be a 5. Okay, this is a 4, so it's a 1-3 pair. It's the only way to add to 4. That looks right, making this 4 and 1. Okay, what can we do now? We know these are from 1, 2, 3. So the 1 is down here. We kind of knew that. Is there anything obvious to do here? We need 3, 4, 5 down here. So this is also from 3, 4, 5. And this is from 1, 2, 6. That's not the 6. Feels like we ought to be able to get something. Oh, how about these two digits? These are 2 and 3. And this 1-3 pair tells us the order. So now we know this is a 5. So this can't be a 5. That puts a 5 here. it feels like we're wrapping up, but I can't quite do it. Okay, with adding to 3 or 4, we know we have to have a 1. So that one is only from there. And it's going to be 1 plus 2 or 1 plus 3, but it can't be 1 plus 3, so it's 1 plus 2 is 3. That makes this, yeah, that resolves all of these. This is 6 now, 2 and 1. Looks like we're finishing. So that's a 5. It just suddenly happened. This is a 4, and then we need 2 and 4 down here. Very nice. Cool puzzle, Riffclown. It seems like the important deduction was finding the 6s and then determining that this had to go here and here, and then the other one of 4 5s had to go from here, had to go here, and then on the arrow. Once you had that, it was very smooth sailing. So cool. Yeah, very neat puzzle, Riffclown. Nice use of arrow geometry that can happen. Knowing that the circle doesn't go on its own arrow is actually very important in a lot of arrow Sudokus when you use sort of the geometric aspects. So cool demonstration there. I enjoyed the puzzle. It flowed very nicely. Thank you. And of course, if you enjoyed this, then why not leave a like, subscribe, and a kind comment below.